So I think this was repeated, all these things, right? Like queens that can attack the king, isn't it?
I think so. At least the last two were repeated.
Yeah, yeah.
First one also was repeated. Yeah, I think.
Yeah, first was also I told Vivek, and let's see, like, okay, let's shall we proceed, right?
Yeah, let's go through it. Yeah, it will be
Okay.
good revision. Maybe people have different opinions about it again, and we might understand in a different perspective. So I would say let's go through it.
Yeah, sure. Okay. So here we are given an array of strings and two strings SNT. Just for a sec. Okay. Two strings SNT are special equivalent. If any number of moves we can make so that string S is equal to string T. Like this S and T, you see they both by swapping X with Z and Y with Z, you'll have this as special equivalent because we may take these are the moves for them. So now a group of special equivalent strings from A is a non-empty subset of A such that every pair of strings in the group are special equivalent and the group is largest size possible. And we are supposed to return the number of groups of special equivalent. Like if you see, these three form into one, like by swapping, uh, what do you say, pairwise special equivalent, and none of the other strings will be equal to them. And again, these two will form into one group. So the number, and this is a separate. So total three such groups can be formed out of that. And same thing goes on over here. And all the A of I will consist of lowercase letters, and they'll have the same length. Yeah. So what would be the brute force here? Like,
Okay, so before the brute force, actually the problem statement, I even when I read the second time this also,
yeah,
so I was a bit not very clear because it says, what we need to do is we need to form groups of these special equivalent strings, right? So
yeah,
even if there is a single string, which doesn't have any pair, so it's not at all a special string, I would say in that case. So it will still form, yeah, that one,
yeah,
ZZYX, correct, yeah.
yeah, yeah.
So it will still form a separate group,
Group,
right?
yeah.
Yeah, so it made a bit,
Ambiguous
uh,
here.
right, right, right. So that is what very key about it. So you need to really read this problem statement very carefully, and then only you get to that. So the whole thing is we have to find all special equivalent strings and group them together and just return the number of groups. Correct.
Yeah.
That's what it says. And other things are like we have all lower cases and we don't have any other special characters or upper cases. So that way it is very easy.
And this is
Okay.
also their same length.
Yeah.
Yeah.
I mean, it's not very easy to implement or even come up with a brute force. So, but at least it makes things very clear about what the problem says, right?
Yeah. Yeah. That's true.
Yeah.
So
And
even if
to,
you have a single string, that will also be counted as a group. That's a one
right,
important thing.
right, right. Yeah. So that's very different thing about it. It doesn't fit in our logic, but that's the way it is. Uh, So going for a brute force, if you ask me, I would say like the similar way, right? You form two for loops. One for loop you start from the start of the string, and then there will be another for loop. You keep on comparing that string with this one, okay?
Okay.
And then keep on increasing one by one. So for that particular string, you will find out how many strings you can add. Will it work actually? I'm not sure.
So you're saying that we take every string as a starting string and then look for all the strings which kind of we can group together.
I was thinking, but I think that will be a wrong way of doing it, right?
But
I think that would be n square. I mean, that might work.
it should,
Uh,
yeah.
no, but see how we will get three of them, like here in this case, A, B, C, D, C, D, B, and whatever this one, right?
Yeah.
So how will be able to group them
So
together?
when you pick ABCD, that is the
Hmm.
string at the 0th index, you
Hmm.
somehow store your even characters list and your odd characters list. Now you go to every other string. check the evens and odds of that string and see that if we get a match with what we are starting with. So if we get a match, then we can group those strings.
Then we can also calculate all the permutations of ABCD and let's see which all of them matches in that permutation. Won't that be also like, I mean, ABCD will have how many? 12 permutations, right?
Yeah, but there is one restriction that we can only swap the even within themselves and odd within themselves.
So, but how do we form a group? That is what I'm not getting to.
So
In a
so for example, ABCD, right? So at the even indices we have A and C. So you store this somewhere, A comma C, and you store B comma D. Now you go to C D A B. At the even indices you have A C and A, and the odd you have D and B. So basically we are interested when the same set of characters are present. We are not worried about the ordering. So
Right.
CD and ABCD, they can form one group. Similarly, you move on to CBAD and you check that way.
Okay, but now, so if we come, so that will be one group, right? Okay.
Yeah, so
And then you won't find any other string matching to that, so that will be one group. You will just move. But then when you come to the next string, like C D A B in the upper loop, right? You will again find another group with the C B A D also, right?
I see.
Yeah, by
You might have
swapping those.
Yeah. So
might
maybe
have
we
to
will have to keep somewhere.
some visited.
Yeah. So that was slightly not very clear. Yeah, I'm missing something here, but it might be much easier than I'm not understanding it.
Once we have found the group for a string, then we don't have to traverse for it.
Yeah, but I like your idea about creating the special equivalent string, right? So you are saying that store the odd and even ones in different sets.
Yeah.
So yeah, that actually is a good thing to do, and that will work for everywhere. That has to work, right? That is the only best way to do it.
Yeah.
Yeah.
I was wondering if we could do without using extra space, because I have maintained an ordered set for doing it.
Okay. So is it possible without
I
an
don't know.
extra
Maybe
space?
there would be a lot of code. I mean, but I think we'll have to somehow keep these even and the odd substring somewhere. I don't know. Maybe.
Yeah.
We can take some kind of a array with the 26 characters.
Yeah. Yeah.
But
Extra space, I
also,
think, would be needed.
Yeah. So yeah, but he's saying that we should be able to do without an extra space.
yeah,
Yeah.
26 is again a constant space.
Right.
That would be 26, yeah. But we need to create two, like odd and even.
Yes.
Yeah,
Yeah.
plus two will give even and plus one will give you odd. So if you
Yeah. So yeah, could we actually walk through any implementation? Anyone
If
has
we try
something?
to sort it,
I
hello?
Or any other good approach? Yeah. Go ahead.
I have a solution. Like if
sure.
okay, can you see my screen?
Yeah.
So I have just taken up one set to store my result, which is so that it should not be overlap when I get another one with the same string. I just want unique strings. I'm traversing my array and I've taken one string, and when I'm creating two maps inside it, and I start with traversing that particular string, and if it is even, I store that and increase the count, and if it is odd, I store that and increase the count. Um, So what this will do, this would like it will like store as a string, store string as a count, like array with count. It is like something 3 comma 0 0 comma 2. So this would be map 1 and this would be map 2. And I'll store that in a set. So why this would be like if I have if in some string I have I only get 2 A's and it is in odd or 2 or 1 over here. So I'll be able to know that these strings are not matching. So this would be that would be not in our result. So ultimately the count would be same.
It will be unique, yeah.
If it is matching as well. So this and whenever I'll be getting the unique, I'll store that and in the end I'll return the length of my set.
Yeah.
This is an ordered set, right?
No, this is a normal set, not ordered set.
We don't have ordered set in Python. Normal.
But why we need ordered set for this?
No, I thought because in C++ we have two different kind of sets. So I asked.
I think that's only unique of C++.
Okay. In Java,
Yeah.
is it in Java as well? I'm sure.
Yeah, in Java also it's there.
Java also there? Okay, yeah.
Yeah, so here I don't think so we require the ordered set, and we just need to match because we are storing that in a set. If that particular kind of string which created is already present in that, will not be adding it, and in the end we'll just need to store. We make a group, and if it is already making a group, yeah. So if the other question would be if they want us to like return what are the groups, then it would be like I think then we should not be storing that.
No, but still, we
That
we
would
should be storing it, but we can actually have another array wherein we will be appending it based on
we can make it like a dictionary at that
right,
time.
right.
It would be this string and value would be that particular string which is matching.
Right. Yeah. So that also is possible. Yeah, good.
That's possible. Yeah. Any questions?
I think this is the very
Best.
efficient way of implementing. Yeah.
Yeah. So because we are traversing particular string and in that particular string we are traversing the length of that string, and in a worst case what's the length they have given, like our size of each string can be goes to 20 and the array length can goes to 1000. So I don't think so that is too much. So it's efficient, I suppose.
Yep.
It has a lot of dislikes, this question. Based on-
Yeah, because the way actually Sonia as well as Harshit said about breaking this into odd and even pairs, right? So that's not very easy to come up with. Even I was thinking very hard on it. And then I said, okay, how can it be? Because if you just read the problem statement, it doesn't occur to us that it should be like this, right?
Exactly. Yeah.
Yeah. Now we have understood this problem, so it is slightly better, Yeah. Yeah.
During initial reading.
I mean, this is n into the length of one string, right?
Yeah.
Yes.
Yeah, it'll be each and every character in the string. Yeah.
Yeah, so if we can go with this 20 and 1000 for this particular question, but yeah, we can go with the n and n into length of the string.
Yeah, I think this is the best we can do.
Yeah.
I made it slightly inefficient by sorting that substring and keeping in a set.
No,
Oh,
but
you
then
sorted?
how
Can
you
you?
share of odd and even position? Because the letters would be different then, right? At odd and even if you sort it.
You're talking about my code, Shashank?
Yeah.
Yeah.
Okay,
So
so
you told that you sorting, right?
Do you want to
Yeah.
share it?
yeah, I can quickly share.
Okay.
my screen is visible.
Yep.
Yeah. So
Yes.
what I'm doing is I'm maintaining a pair. Before that, I've used a set, an ordered set, and so I've maintained a pair also. In my first element, I'm putting all the even ones, and in the second, I'm putting all the odd ones. So and then I sort them, and then I put them in my set. So I'll give an example. I'll quickly give an example. So if it's A, B, C, D, then first would be AC and the second would be BD. So this is already
Okay.
sorted, right? So I put this in my set, and for the next string CDAB, so it would be CA plus DB. Now after sorting it, it would be AC, and I individually sort them, AC plus BD. So these two are the same, this and this. So they would be counted as one group. So I would not be inserting this AC plus BD the second time because I'm maintaining an ordered set. So this was the extra part I'm doing. This is the extra part.
Okay.
Yeah.
Makes sense.
This makes sense then, yeah.
Preserving the first is dividing into two groups and then sorting.
Right.
Yeah. So, but again, it will take n log n yours, right?
Yeah. So it would be n into length of one string into log of that string.
Yeah. So if the string's length is m, that will be n into m log m.
If the string's length is n and we have total m strings, then it would be m into n into log n.
Yes. Okay. That's a different way of looking at it. Yeah, that's good too. So you are not maintaining, or you still have to maintain an extra space. Yeah.
Yes.
Yeah,
Extra
yeah,
space is being used here and here. So yeah,
yeah.
could have dealt with the count the way Sony has done.
Mhm.
Okay.
Yep, this is good. Yeah.
A quick question. So what is that first dot begin and first dot end in C++?
So this is basically an iterator. So dot begin takes you to the first entry in your particular container.
Okay, so
And-
it will sort from first to the end. Okay.
Yeah. So end is one step ahead of the last. So not the last, one step ahead.
Okay, got it. Thank you.
Yeah, Shesha.
So our next is this queen problem. Yeah, the queens that can attack the king. So 8x8 chessboard is there, and there could be multiple black queens on one white queen. So here it's like the king is here, given an array of integer queens that represent the position of black queens, and a pair of coordinates of king that represents position of white king. We are supposed to return the coordinates of all the queens that can attack the king. So this red one can attack, and then so
Yeah.
this can attack, but this can't attack because it will be blocked by the red queen here. Again, this will also be blocked by this, but this can attack. If it goes diagonally, it can attack, and further, like down also you have. Sorry, you have to clean the diagonal. Right?
Yeah. So the ones which are covering the queens which are covering the ones which are behind them, they won't be in that picture, right? Yeah. They won't be in our answer set.
Exactly. Same thing they are explaining here. So here again we can see this. Only 3 will be able to attack because the others 2 will be blocked by the red one, and the diagonal 2 will be blocked by this again red queen.
Yeah.
At most one piece is allowed in. Yes. So what would be the brute force here? Like,
Yeah. So this is a very, what do you say, like sort of a BFS traversal, something like that, right? It,
yeah.
it appears to be. And but I'm not sure whether we should be able to do it slightly better also, because BFS you might keep going each and every level, or you might have to stop at some level, and here in this case then you have to stop at the
It,
directions, right? Yeah.
mm. And it's a finite also. Second best thing is this. Like, I mean, chessboard is finite, right?
Yeah, it's
Oh.
into it.
Yeah, 8 into 8. Had it been infinite, then
But this is here, in this scope. But if it was in an interview, he will surely make us slightly difficult, right?
exactly. Yeah.
Yeah. So he may say, okay, it's 8 now. I want some different game. It's not the same, but similar to a chess, and then you have a bigger one. So we might have to think. But still, it should not matter, right? If the rules are the same, both sides should not matter.
If the board size is pretty huge, then I think it will matter. If you do like simple normal BFS or DFS, in that case, the board size would affect, I think. Yeah, I think one of
Right.
the approaches would be more useful if the chessboard is infinite.
Hmm.
But then also we can, like, if we traverse from king to the queens, whether it's a finite or infinite, it doesn't matter. Because we need to move to 8 directions of king, and as soon as we get the first queen, we'll just return back and we'll traverse to the other direction.
No, but actually, Ronnie was saying that if he implemented the BFS or DFS way, then that might be a problem. But the way you are saying it might be an optimized way of implementing.
Right. I think if the chessboard is infinite, then rather than starting with the king, I think we should kind of go to each queen and then work on it. Rather, I think it should be the opposite.
Opposite,
Because
yes, I think so. Maybe, yes,
Yeah.
actually, there's a point. We can look at it that way also. But I was thinking it that way.
But
Maybe he has some different way of, yeah.
but someone was saying that only the king can be hit by 8 directions. So why not we just explore 8 directions, and if we found very first queen, those would be our answers. I'm saying only 8 queens can like, it doesn't matter how big is the chessboard. The maximum 8 queens can target king.
right.
Answer would be 8 queens, but because if our, for example, king is in the middle and it will
Yeah.
have to go to the end of the chessboard, the
It
queen
can
might
attack
be
this.
there. Yeah, the
That is
queen.
what
Excuse
I'm.
Yeah,
So we can like, if we assume the king is in center, then we can look at all the potential places from where the queen can attack. Yeah, so if the king is at the center and we have an infinite chessboard, then, and if we take this king approach, like starting from the king, would that be not very inefficient? Because we'll be traveling a lot of
It
but the
will.
key,
But then you are planning, Harshit, your approach was like you take each and every queen and then find if it is closer to king. Is that the way you're thinking?
yeah. So I think even in that case, we'll be exhausting all the potential, all the possibilities, right? So will it be better? I don't think so.
Yeah, because if there are many queens, you are going
Yeah.
through each and every queen. So that might be more time complexity.
Yeah, in that case.
This is just my thoughts, but yeah, I'm thinking loud, so we can come through that also. Yeah, but one way is go through do a BFS or DFS, and as Ronnie and most of us actually are saying, it will be not so efficient way of doing it, and I think we'll hit on a TLE at least in lead code, right? So the other way would be to go take the king because it's only single one, and then go in all the directions, and then just stop whenever we wait on a queen. But if it's a big board, then yeah, it might go to the end. That is one. Yeah.
So in
How
that
do
case,
you
you
go about
starting
with the
from
BFS approach?
I'm sorry.
So I'm asking, how do you like start with the BFS?
Well, start take the coordinates of the king,
Okay.
and then you go all the 8 directions.
Okay, that way. Okay.
Yeah. But only thing is when you should stop entering in that the location in a queue will be whenever you hit on a queen. At that time, you just stop, not putting that in the queen.
The first queen for that level.
Right.
So whenever you see the first queen, you don't need to look for the second queen in that
In
direction,
that
right?
direction. Right.
Yeah. That's
But
an
that
optimized.
hits a TLE, I would say. It's not a good way of doing it.
No, I think I've done that way only. I've done using the king approach only.
Okay. So you are able to
Yeah.
get it accepted? Okay. Maybe
Yeah,
there
I
is
did
something.
with starting from the king and traversed, and it got accepted.
That is why I was more inclined to the queen's approach, because this came naturally to me, the king one. So I thought somebody could have done that.
Yeah.
I just thought that would be more optimized.
I think Uday had something when he was discussing the
Yes.
same thing last time, right? And then we had so much of back and forth in the Discord also. Yeah, but I still don't remember what was that about. But yeah,
I'll try
There
to
is
look
not.
for the solution maybe.
yeah. Okay, so let's go with
Yes, Sonia,
whatever
Harshit.
yeah.
So this is what I've done. So I've first maintained 8x8 vector where I've stored my indices of the queen. Like the row is the first index and the column is the second index, and I've marked it as true. Now I've simply traversed in the 8 directions using these 2 loops where I've started from -1 and I'm going till 1. And if my I comma j are 0 is 0,0, then I skip, because that would mean that is my position of the king only. So next thing is that this is my starting x coordinate for a particular direction. So it would be king of 0 plus I. So for example, if I'm going towards the left, so it would be -1. This would be -1, and my column would be 0. Okay, so the next thing I'm doing,
row would be 0 and column would be -1, right?
Sorry, yeah, row would be 0 and column would be -1. Yeah, so this is okay. So till this is just to check the boundaries, this condition. So, and if I find a queen, I'm putting that coordinate of that particular queen in my result vector and I'm breaking. So I come out of this while loop, and yeah, and then I check for the other directions.
Okay, but this is not a standard BFS.
Yeah, that's why I was asking.
Yeah, this is the most efficient way of doing it. Yeah.
I can share the DFS which I did.
Okay.
And here, if you do one early check, you can do if the length of your res is equal to 8, then you can directly break from there, right? I mean,
if my length of the res is equal to 8.
Yeah, that means all the 8 directions the king was surrounded. So there is no point in exploring further.
Right, makes sense.
So that you can exit.
Yeah.
Just line on line number 16. This is a nice way to implement this.
Yeah. Because I was starting from the king and going all the way. I did 8 for loops. So this is a very concise way of implementing. Yeah, I like that.
But anyhow, you have to go to the 8 directions.
Yeah. We have to. Absolutely.
Okay, I think Sonia is sharing something.
Sure. Thank you.
Please share this code, Harshad.
Okay, sure.
Can you see my screen?
Yeah.
You increase the font a bit.
Yeah, please. Yeah. I was about to say that.
Is it okay?
Yeah. Slightly better.
Okay, so as Harshit said that I have created a visited, I've also created the visited set array with the 8 by 8 of 8 by 8 and traversing each direction. Like my king is, for example, at the center, and first of all, I'll start with my moving ahead with one direction, and I've created that self dot directions over here. And I have created one function which is like a safe check, where in a like it should be in bounds. And one thing is which if it is not already visited, I'll make it visited and then traverse to that direction. Like start moving in that direction, and in that direction I already also pass those directions, like which direction it should move. Like for example, if it is going in 0 1 sorry, is this one right side, so it should be the direction should be like if it is in DFS, it should be like 0 1 plus and 0 1 plus 0, like it should always be going towards the right direction, not any other direction. So that is a part of the DFS which I am doing. I am doing a safe check. Then if it is already in a, if that row and column is already in my queen set, then I'll appending in my result set and directly returning it. If it is not, then I'm marking it true and adding those directions 0 and 1 again, like I am moving ahead in that particular direction by adding that 0 and 1 in my previous row and column, and then doing a DFS again. So this would be the check when, like, as soon as I'll be getting all these, when one direction is done, like if as soon as I get one queen, I'll be returning back, and my other direction of the king would start. Like if I was going with the right direction, I'll go to the top, left, like all the diagonals and down. So this is one solution, and I'm just returning the result.
So were you able to get it accepted in the lead code?
I think I have done something, changed some changes. Yeah, it was accepted.
Okay.
Yeah. Little bit changes I have done.
Because of finite chessboard, it is, that's why I think. Otherwise.
But that would be problem in if we traverse all the queens first of all as well, or not?
Pardon?
So if we traverse all the queens first,
okay,
then also it is a problem if it is a infinite set, infinite chessboard.
Yeah, it should be.
Yeah, because it's anyhow, if it is infinite, we need to go. I'm interesting to see the solution if people have done like traversing all the queens rather than going from a king side.
In most of the solutions, also, like they have started from king itself.
Yeah. But is this implementation DFS almost similar to what Harshit did, right? Sort of, because she's also looking for each and every direction and going to the queen and then returning back if she finds it, right? Or maybe just terminating it. So Harshit is also doing it, but here you are using a recursive call stack, right?
Yes.
That's the only one difference, I would say, right? Am I thinking correctly, or?
Yeah, it's same. He was taking a while loop. And instead of while loop, I just used another function with DFS. That's also a recursion, but I don't think so. While loop we count as a recursion. It would be like an iterative way.
Yeah, that is the most efficient way of doing it. But this also looks similar to that, right?
Yeah,
Bit
that's
closer to DFS it looks, I mean, than
Mhm.
Harshit's because of this visited
Mhm.
and
it is more sounding like what directions we would be going, how DFS would work, uh, like how the template of DFS is there in our mind.
Mhm.
So keeping in that in mind. So
Right, right.
okay, but yeah, so that solution is also worked, and that is more efficient. I would
Right.
efficient for efficiency way. They both are equal, I suppose.
yeah.
In big of terms, it is, but only space, because of the recursive call stack, as well as the call stack will always have an overhead, right?
Yes.
In the time complexity also. When you do profiling of each function, then
Okay.
surely it will give more. That is what my thoughts are.
Okay, makes sense. Thank you.
Thank you.
Yeah.
So I have sent that Uday's solution, which
Oh,
is
really?
O of queens in the chat. Yeah.
Okay.
What was the intuition?
Let's open it and discuss this maybe.
Yeah, please, I would say that will be better way of doing it.
Chill.
Is Uday here?
No,
Uday
he is
is
not here.
Bad luck.
Now we have to dig in. Okay.
So first you have to find all the directions, all the 8 directions, right? With the corresponding
Right.
to them.
So he's iterating over the queen's array first. I think from
Yeah.
line number 15. Okay. And
So what is that? 18? If size equals to 0. So
if
So the get IDX actually gets the index of the
queen and king.
and king.
Yeah.
queen and king.
Queen and king, yeah.
Yeah.
Okay. Where is this function? Get IDX.
It is on line 67.
Okay.
So the way he is doing it is just finding whether it is left row, right row, top column.
I think this is the crux.
Yeah. So he's just identifying in which direction that king and queen are. So he's trying to find that direction.
Yeah.
Okay. So it comes in get the IDX. So you know IDX, the value in which direction it is. And then in that actually he tries to, if there is a queen, so that is the first queen, he marks that. So he doesn't return to that anymore whenever you find. So he's just stopping that and terminating that direction. And then he's updating again. So what is this update with? So RES, which is the result. So that result, yeah. So that result actually, if the queen, king, and IDX, he just
Updating might be for a better queen. Like if he might be finding a queen closer to the king, then he might be updating it.
so he's going through each and every queen, right?
Yeah.
Yeah. All the 8 directions.
But is this not more time complexity?
I think a lot of lines also.
Yeah, bulky. The code is too bulky, I think.
Yeah.
And complexity, lot many of if-else statements are there.
No, but that is still fine. But I would say that when you are going through combination of each queen and each time queen and the king, so you are exhausting more than the 8 directions, which might not be required, right? But he said it is very efficient. That is what
Yeah,
his
I
claim
think
was.
it's efficient because in the index function, he's just comparing the particular coordinates.
Okay, because he's not going
Yeah,
anywhere, right?
that is just a constant function, I believe.
So I think this question came up because if the board is infinite, and then if in some paths if we don't have a queen, right? So then we will end up iterating to the end of that, right? So it might be if the board is very big, you know.
Okay.
So then in that case we might hit a TLE or something like that. So to
So
avoid
yes,
that, he is actually looking for the queens. Yeah,
yeah. So that is what I was thinking.
yeah. The scenario is slightly different.
Because here it's just O of queens.
Hmm. Right, because if it is too big of a board and then we have to, if there is no queen in a path and then the king, even if we start from the king looking to the end, if you go that via the DFS approach or even the normal iteration approach, still
Yeah.
actually it will be a big uh, time complexity. So to
Yeah.
avoid that, he did it this way. Yeah, okay.
What is this partition thing on line number 25?
Yeah, I was also about to go there. Yeah.
Partition function, it is.
Yeah, okay. He's doing a partition.
Where is this function defined?
No, it's not defined. It's a steel function.
Oh, it's a STL function. Okay.
Hmm. It's something to do with, I think, the some ordering. I didn't use it anywhere, anytime, so I'm not sure of what it is. Let me quickly look at.
But again, coming up with this approach in interview is
Yeah, but this is like in case if we are the way someone comes up with, okay, if the board size is very huge,
Yeah.
and
yeah.
if we don't have queens anywhere, you know, so all our other approaches might be of a big time complexity. Even the
Yeah.
O of n, it won't be, you know. So then we'll have to come up with a different approach. So this might be a good way of coming up. So yeah, what it says about partition is partition refers to act of dividing elements of a container depending upon a given condition. So the last element is a condition, and then so this is that condition. So whatever the comparator function, what he's using.
I think it's
So
just segregating on the basis of size. So if it, sorry, on the basis of whether it's empty or not. If the vector is empty, then it will be segregated. Else, I mean, just based
okay.
on it's empty or not.
So yeah. So if it is empty, he doesn't want to include them in his answer, and therefore he
All right.
erasing it. Yeah. Okay, makes sense. Yeah, good.
Okay. So he's getting that index and then updating primarily for
Yeah,
in the queens array.
yeah.
Yeah.
Hmm. But that's a really good way of thinking, right? Because if we have a scenario, the way
infinite just
infinite, yeah.
works.
Because we would never go that route. We would never think it.
Yeah.
We always
Yeah.
start from things still, yeah.
Maybe what
So
we can do, I mean, just a small, optimization is that we can find the distance between each as a pre-processing between each queen and king, then I think we'll be able to simplify this get index function or the update function, maybe the update function, I believe, because then we can choose the smaller. No, that distance won't work, right?
Come again.
Closest distance we can choose.
So I was thinking that if we kind of find the distance of each and every queen with the king, and then store that distance somewhere.
Okay.
And pick the closest one.
Yeah.
But how will you make sure that the other queen is falling in the same path or same row or same color?
Yeah,
that distance won't work, right? Because the angle also is important.
Yeah. So the direction is very important than the distance.
So how will you keep track of the direction?
No, so that would be a separate thing to take care of.
Some angle, something like that, right? You can fall into same angle.
But that would be possible because anyhow, if one direction would be greater than the other direction, like for example, if all the queens around surrounding that king are in a same distance in all the directions, so that uncountable means that, because it's not possible that uh, if one queen's distance is greater than the previous one, we always take the earlier one.
But that
yeah, so we have 8 unique directions, right?
Yeah.
And for every particular direction, we can deal with the slopes. Like if for the same slope, I can choose the queen with the minimum distance. I'll have to find the slope by using that formula y2 minus y1 upon x2 minus x1.
Yeah, you can assign that northeast, north, south, or southeast, something like that, right?
Some kind of a mark, like this is top one, like by storing the distance of that particular queen from the queen, we can also, along with the distance, we can add that direction as well.
Yeah, right.
Maybe form a set for each and every direction, or maybe a dictionary. Yeah,
with 8 keys, or maybe maintain a main heap, and in that heap we'll put the distance only. No, a map would work.
Along with the direction.
Yeah, dictionary or map, yeah, should be okay.
If we see a queen already computed for a particular slope, we kind of maintain, if we kind of check if that previously computed queen has distance lesser or our current queen.
And so when calculating a distance, will be like just look at the coordinates, right?
Yeah.
I think that is also a good solution, right?
Coordinates from king to the queen.
Anything, we can just take the absolute value and square and add and take the under root.
Yeah, king to the queen always, correct. But then we'll have to get an absolute value and then put that in that dictionary or map.
Yeah.
Based on the direction. Yeah.
This would be O of queens only.
Yeah, that is true. But there is no other option in that case, right? If it's an infinite board, so that is the only way.
Yeah.
We could do. Cool. Yeah. So that should be possible to come up with an entry, I would say, right?
It looks possible.
Yeah. Good one.
Only a little bit with the direction.
Number of directions are limited. We have 8 possible directions.
No, 8 also. No. If 4 you find, the other will be negative of that, because if one is at 45 degree, the other will be at 135, which will be minus of, one is in clockwise 45 degree. So other will be opposite. One is in first quadrant, the other in third quadrant. So it will be negative. The slope will be negative of the first quadrant. So if you find 4, so the other 4s can be complement of that.
Yeah, 4 different slopes.
Yeah.
So I was just wondering whether we will have, other than 45 degrees angle, will we have some other queens in between those angles?
No, because only diagonal is there, which is at 45 degree, and others will be at 90 degree rows, straight rows and columns.
Those are the only attacking positions.
So we'll have to take it that way, right? If it's some queen lying in not any of the directions, then we'll have to just ignore that.
But it will
Yeah.
not be possible to do lines in any other direction because it would be always be diagonals.
Or straightforward rows and columns.
Yeah,
Yeah, even if it's there, then we won't count them because they cannot attack the king.
Right. But we'll have to, take care of that.
So if any slopes apart from 0, 90, -1 and -45 and 45 won't be counted.
0, -1, +1. That's and pi by and 1. What do you say?
Infinity.
Pi by 4 will be what? 10 of pi by 4. 1 by root 2, something like that. 1.
So 0, 1, -1 and -1 and 1, right? That's only.
No, 45 degree is also there now.
Yeah, so 45 degrees. So angles would be 0 degrees, 45, 90, and this 135.
That's
Yeah.
Yeah. No, 135 is like what do you say?
Same as 45.
Yeah.
Yeah.
0, 90, 45. That's it.
Yeah. So we just have to compare the XX and YYs of each queen, king, and queen, right? Yeah.
Yeah.
Just the slopes.
Yeah. Therefore.
Difference of x by y by x or x by y, something like
Yeah.
So that's a good one actually. We came up with a good approach, I would say. Yeah.
It's a nice one. Bit mathematical, but it's got.
Mathematical as well as programmatical. Yeah, both.
Yeah.
Because we are using a data structure of map, right?
Yeah.
Cool. Yeah.
We can switch to next then.
Yeah.
So what was your approach, Shashank?
Yeah, same like king. Mine was. Yeah. Like same. I took the kings. Sorry. Yeah. So here I'm the normal DFS. Like I'm going in all the directions, all the 8 directions. I mean diagonal, non-diagonal, all those things. And then I've defined a DFS function in which I'll take the kings at 0 and kings at 1, and along with the 0, 1 is like row and column. I'm taking the position of the king and passing the next. Like if I want to go to diagonal, then for that RO and CO. So this will go to the DFS function and it will again check the boundary cases, whether row greater than 0 or if it is less than your number of rows on the board, column greater than 0 and it should be less than your calls. And if queens is present in that case, that means it can attack, so it will return from here and then subsequently go for the next row and column. Otherwise, if it is not, queen is not present, then it will return none. And here I'll check whether I've got none or some position. If it is none, if it is not none, then we'll store the position of that queen of that result. And this is like if we found that early, if we want to exit, if we'll check whether the total directions, if that king is occupied on all 8 sides, then we don't need to move further and we'll return rest from here itself in that case. Otherwise, we'll traverse the entire and return this.
So you are using the DFS approach? Yeah.
DFS approach, yeah.
Yeah, that's good. This is also very efficient, yeah.
Yeah, it's same, yeah. So it will only take like order of 8 time all the 8 directions which you will be looking for this one.
Yeah.
So it's a constant only, yeah. And this while loop will take again rows into columns, right? It will go through the entire chessboard. So that's also order of 8 cross 8.
Yeah.
So yeah, overall. It won't be constant, right?
But why do you go as a while loop? You are using a DFS, right? Okay. You are iterating inside the DFS actually.
Yeah.
Okay.
Call stack I'm not using, yeah.
Correct, yeah. That's good.
Yeah. So our next is this snake attack. Minimum moves to reach the target. Yeah, it was like, I think what we recall. We have to read it again. Move one cell to the right if there are no blocked cells, right? Okay. Yeah. Somewhat I'm remembering.
Yeah. So actually, the snake is that occupies two positions. If you
Yeah.
go to the very first big yeah.
Okay.
Here you
Yeah.
see it occupies two positions. One is 0, 0 and 0, 1 always.
Okay.
So it will always be of two positions. So one will be head and other will be tail, something like that. And then we keep on moving it in horizontal direction. In horizontal direction, maybe like if there is a 0, it can move. If it is 1,
Straight.
it is a block.
Yeah.
So he cannot go there. So he keeps on moving. So if, or in this case, he can move horizontal 1 and another horizontal. So two positions he can move, and then he can actually move vertical down. So because then he has 0 zeros below it, right?
Yeah. And you
So
can. Yeah.
yeah,
So, one time it will occupy two cells. Is that
right.
Yeah. It will always occupy two cells.
either
And
horizontal or vertical?
Yeah.
you
Or
can flip
either
also, right? If bottom is not blocked, is it? I mean, I'm what
right.
I'm remembering.
Yeah, that's correct. So you
Okay.
can actually first go horizontal, or other direction is you can go vertical, or then you can go clockwise and anti-clockwise. Right. So there are
Yeah.
4 directions you can actually take. So
Yeah.
if you just go down, he has explained it, right? So what is clockwise and anti-clockwise? And so when he can go clockwise only when he is in a horizontal position, and if he's in vertical position, he can go anti-clockwise. And so whenever he wants to go clockwise or anti-clockwise, the other cell which he is traversing through also should be 0. And if it is 1, he cannot go.
So in vertical, you can't make anti-clockwise.
Vertical, if he is vertical, he should be able to go anti-clockwise, right?
Because let's say snake is like this.
Uh-huh.
So this is anti-clockwise, right? I mean, it will rotate this side.
That is clockwise, I think.
Clockwise, it is. Okay.
Yeah, that will be
Okay.
clockwise, right? Yeah.
Okay. Let's say if these two blocks were 0, 0, then can't it make sweep like this?
Yeah, then it should be. That is a anti-clockwise.
This is anti-clock, right?
Yeah.
Yeah. And this is clockwise. So so when it is vertical, it can make movements in both the directions, right?
No, but they have restriction, it seems.
Both
If
they
you
have.
go
Okay,
down,
fine.
yeah,
Yeah.
you can just go in one direction.
Yeah. Top they might have mentioned.
Yeah, it is mentioned. Yeah, these two cases. Yeah, this one.
Clockwise. Yeah.
So if it's horizontal, he can go the clockwise. This is the way he's showing. Okay. So in that case, the other cell also should be 0, 0. The cell which is traversing, which is in this case R1 plus R plus 1 and C plus 1.
One.
So that
Okay.
also should be 0. And if you want to go counterclockwise, then the snake should be in vertical position, and then it can actually become horizontal actually in this case, right? But when he's traversing again, he has to look for that cell which is R1, R plus 1 and C plus 1. That cell also should be 0.
Yeah, so in the clockwise movement, so I don't think that cell R plus 1, C plus 1 is being used.
It's not being used, but it has to be 0. If it is not 0, then you can't make that move.
Right.
These two 0, 0, it should be vacant. Yeah.
Yeah, I would say all of them should be zeros in that case if you look the whole thing. But for our comparison, it will be only one cell we have to always compare, because anyway, other 4 cells we already know, because in one, the first 2 cells he's already there, so he's always 0. but the one which is going to go also should be 0, but he's traversing through other cell, that also should be 0. So that's only one additional condition we have to check.
Yeah.
Yeah.
I think that is an intermediate.
Yeah, the intermediate one. Because that is the reason when I was working on it, I just ignored that cell and I was trying it. But some test cases it was failing. And then I tried exploring all the discussions. So I came to know this is something which I missed. Because it is written in this problem statement. It's very lengthy, but somewhere they mention it.
Can you walk through the example solution, like of example 1? Because so it's little bit confusing how they are getting 11. So which cells it is occupying? I'm just confused.
I think first they might be going like this, right? Because only this is the direction initially.
So it's right. First of all is right, which is this cell.
Yeah, then it will.
Then again right, which is this cell. Then rotate clockwise, which is down.
No, from here you are telling it will make clockwise, right?
I think it will go only, okay. Yeah, it will go 2 rights, that is 2 horizontal, and then do a clockwise rotation.
Yeah. It will not go this side,
Yeah.
So when it will be clockwise, it will become vertical.
Yeah, so it will be in this.
Clockwise,
not that, the near one.
But then it is
I think the condition is that there should be 2 zeros.
So it is in this cell.
Pardon?
It is other direction is after rotate clockwise, it's saying right. It's not saying down, it's saying right in the explanation of this solution. So might be this is not the path.
Okay, let me quickly check.
Second row is a path. Second column is a path.
Right, rotate clockwise. Yeah, right means 2. We are going correct only, no? Right means those 2 zeros it will cover and then it will go down.
Yeah.
But after rotate clockwise, it's saying right.
Yeah, right again here. 4 cells are again right. It is going.
Yeah, actually, see, if you go to first right, you just mark that one cell, just by cross, and then it will be on the 0th row and so you just wait over there, and now you go clockwise. So you keep your cursor clockwise down, so it will be vertical.
Yeah.
No, this other side, yeah.
Head will be where?
Head will be on 0th row and second column, right? And tail will be on first row and second column.
So this is my head, right?
No. You are doing it the other cell. You just come one more to the left side.
Column before.
One column to the left. Yeah.
One column left.
No. Left.
Column left.
Okay, left this side.
Yeah. So that will be your head, and the just top one will be your tail.
So it will be lying vertical, like horizontal, like this, right?
No. It will be vertical.
You can refer to the diagram. That description.
Okay, can you draw like here?
Okay, let me do. I'll try to do that.
Yeah.
Just give a minute.
Snake body is flexible, like.
Okay. So see, this will be our first movement. Oh man, I selected the wrong format, right? I need to
Red
select.
color, right?
I will select a different color, so that will be. Okay, I'm not erasing it now. Okay. So this will be my first right movement. Okay, horizontal movement. Second horizontal movement, and the clockwise rotation will be like this. Okay. So I will be here now.
And result.
Yeah. So that is the direction I will actually go. And then when what is the next direction where he's going?
Right.
He's going right.
Mm-hmm.
On the 0 to the right.
On the right side of where it is, the head is there, or it's right side. You can make it.
Well,
clockwise.
Can you draw the head also, like head, mark head with arrow?
So right means again, okay, he's actually going this way.
The second row.
So he's going like this again?
Yeah, this way, right.
Okay, he does a change and then so it's becoming vertical. So this will be like this. So it will come here, then it will come here, right?
Down,
Yeah.
two downs.
Yeah. Can you scroll up a bit, Shashank?
Yeah, sure.
Okay, it's going to
Oh,
mess up,
sorry.
but no problem. Yeah. Yeah. So, okay. So this is our first position. This is our second position. This is our third. Then this is our fourth, right?
Okay.
Then this will be fifth, sixth,
6.
seventh, eighth, and now it will actually flip here. It will flip here to ninth position, correct? Then 10th, and then this will be the 11th one because you will just jump vertical, right? Both of them.
So I
So
can't
8 to
move
9, how is going?
8 to 9 actually is going in anti-clockwise direction here.
So the head where it is pointed, that's the move which we need to count.
Right. Yeah.
Where the head is.
Yeah.
Okay. So the other option could have been like from 8, he would have taken 2 steps.
Straight like this.
Yeah, he could take it this way. Yeah, that is also possible like this. Both will come here, right? And then it will take another anti-clockwise here and then again come vertical down. Yeah, that is also okay.
So what is the final? Like it has to reach the bottommost cell, right?
Yeah, so it has to reach this position.
Answer
Then
is
why? But why then? Why it will go like once the snake is here, he will directly go here. Why he will go here and then again go to here and then here?
Because he has to make the head point to the last this cell.
Yeah. So till now the head was like this. Arrow represents the head.
Right.
Now it will turn this side. Head will be here, right?
No. So you cannot make the head just like that, right? Okay. Are you saying that you want to go right?
Yeah, right.
Yeah,
Right like this only. Again,
yeah.
I'll go from
So
here.
if you go to right, then you're actually okay. So
I think
you're
that's not possible.
so you're right. Okay, let's check what he is trying to say. So okay, so your head will be this snake will be here. Okay, maybe I'll take a different one. So your snake will be here, right? So then it can move like this to the anti-clockwise because then your head will be here and then you come down again. So in this case, it will be here. Right?
Yeah, I think what Shashank was saying is that once we reach the 8th cell, he was saying that we take 2 forward steps.
Yeah, straight.
No. 2 forward step will actually not be possible,
Why?
Yeah. Because when we are on the 8th cell, the head is on the 8th cell, then we have to kind of rotate.
Yeah.
Yeah, so
that is a small trick actually. Yeah.
Oh, it has to rotate. I mean, like
direction change.
So it will go here first. Like a head will be here and tail will be at the bottom, right?
Yeah.
And then again go here.
That's the only one thing. Yeah. It's very different. So if you mess with that head, if you don't, keep an eye on the head and tail, then you will land in a wrong place.
Direction.
Yeah.
Very.
It's a weird question.
Yeah.
I don't see many companies asking this question also.
You never know. Nowadays people ask anything. We should be
This
ready for
question
it.
might have been asked, I think.
Yeah.
Yeah, I can see just one company, Kakao.
But at least it gives us some exposures, to actually keep an eye on all these small things which we really need. Yeah.
And secondly, why the snake went here? It could have, it went here, and then from here it could have.
No, that's the only way you can go, right? Because if you have to go clockwise, you have to be horizontal. And you have to have all the 4 cells which you want to go, right? So like this cell should be 0, this cell should be 0, this also should be 0, this also should be 0. And you have to be in a horizontal position. So if you would have been in something like this position here, okay, you cannot go here, right?
Yeah.
And you cannot bring your tail here also, right? You cannot be like this also with your head pointing on the top.
Full body, it has to move first there,
Yeah.
and then
Yeah.
nice one.
Yeah. Somewhere a snake is clumsy. Yeah.
Yeah. Okay. So for doing clockwise or anti-clockwise, all the 4 cells should be empty.
Yeah, that is the way I look at it. Yeah.
Yeah.
So how do we implement it? Because I don't think there is any brute force in this. If there is one way, there is an implementation, there is only one way of implementing it.
BFS.
BFS,
The
right?
first two moves look quite straightforward.
Yeah, the first two are straightforward.
Yeah, and for the next two moves, we'll have to check these the cells,
Below cells.
which need to be empty.
Yeah.
That is what I can see.
Yeah. So BFS also, when I actually did it the way what I thought would be a good way of doing it, or maybe at least I thought it is the right way to do it, maybe because of my limited understanding, it gave me a TLE, you know. So
Even
I had to slightly tweak it. Yeah, sorry.
they're using DP, like, because 4 possible directions are there. No, like if you have gone horizontal, then from there again 4 possibilities are there. Like either you can go horizontal, or you can go vertical, or you can go clockwise or anti-clockwise. So 4 possible choices are there after every transition. So somewhat they were using as DP also.
Yeah, I didn't understand how to do a DP way, because that was slightly difficult for me.
Yeah, it's not pretty intuitive. I mean, that intuitive, but
No, it might be possible, and it might be the efficient way of doing it, because the way I did, my timings are not so good, but it is okay. So I think there might be much better way of implementing
So
it.
that BFS only first.
Sorry? Sure.
I think let's go through the BFS first.
yeah, that is more. Yeah. So, I'm stopping.
Someone sharing it, or should I share?
Oh, mine is DP. I mean, what I saw. So, should I share? Oh.
I think Harish is sharing, right?
No. I was saying Santosh's approach we can discuss. BFS.
Okay, let's go with mine, because it might be slightly the non-efficient way, but yeah. So then we can come to your discussion, Shahram. Okay. So actually, I did the BFS. First this guy, actually the one which I implemented, was not so efficient. Okay. So these are some of the helper functions I'm using to find whether it's in horizontal position, vertical position, just to look at where my snake is. And then I'm trying to see if it is valid. So the validity is like the cells are actually 0, 0, and if it is within the bounds and all that stuff. And then I'm actually creating a string with all these parameters of the x1, x2, x2, y2 of that snake. And I want to store it somewhere. So this is the main entry function. And these are some of the checks. So to see if the last 2 rows are not zeros, the last 2 cells are not zeros. If they are 1, then it doesn't make sense. It will always return -1. And then this is our BFS approach. I set a queue with vector, and then I just push in these 2 coordinates of the tail, and then this is the head, right? And I also have, this is my queue where I push these 2 coordinates. This is the tail and this is the head. And then I'm maintaining a visited unordered set also, that I'm pushing the same values, 0, 0, 0, 1. And this is the place where I'm using the toString. So I just want to store them. And these are the 4 directions. So the directions for each and every, the tail actually will move horizontal, and also the head will move horizontal, one position. And this is the way actually it will move vertical. The tail will move down and the head will move down in this case. And in this case, it is 1 minus 1. I think it is clockwise, right? Yeah, it is clockwise. And this is the anti-clockwise end. Right, so I come in this queue and then actually go through this. I'm just trying to maintain a level, therefore looking for this for loop here. And then when I come here, just pop it out, take all those 4 values for the tail and head, and then look for if I am at the end. If I am at the end, I just return the moves, or else I go through each and every direction. Okay, and when I'm going through each and every direction, I look for, like, if it is 2, means if it is clockwise. So I just check if it is horizontal first. If it is not horizontal, then I actually just continue. Or if it is horizontal, if it is valid, okay. And then, so I also look for the valid, the X1, Y1 positions. Okay, the one which I want to go, and the one which this is for the tail and this is for the head. Yeah. So I just check all of them, and then I also check U2 plus 1 and V2. Okay, so that is the one which I'm looking for. So that also should be empty, the other cell which we are just traversing through. The same thing I do for the anti-clockwise. Okay. In this case, I look, if the snake is vertical, and then I look for all these valid cells. Yeah, and then if it is not anti-clockwise, clockwise, then go down, and this I check if it is if X1 and X2, sorry, the tail and head, the new tails and head, they are actually valid. And then I come here, and then if everything is fine, then I actually store that new the locations in the mice visited set, and then put in the queue. Okay, and then then I insert this. I actually insert here in the visited set. Here I'm just checking if it is there in the visited set or not. So just to avoid coming back again, and this increase the moves. So that was actually going through, but the only problem in this case was this 2-string, too much of 2-string calculating and all that. It was hitting on a very huge, what do you say, timings. Yeah, so it was like something 1332. So I was able to optimize it, bring it to something 140 or 272. It was a similar approach, but only thing is, but only what change I have done here, in this case, my horizontal is the same, vertical is same, valid also same, but I'm just creating a 2-param, something like that. I'm just creating an integer over here, okay, instead of using a string. So I'm just using that integer, and so modified my visited array. Visited array set actually, and just putting it in integer over here. So other than that, everything remains same. And when I'm actually looking for, so the clockwise, anti-clockwise, so I'm not actually, I was looking for all the cells, right? The validity. I'm just looking for the ones which I'm going to visit. So that is a small change I made. And if I actually run through, I get a better timings in this case. So yeah, so that is the only minor change I made, and it worked. It was not so good at timings, but it is slightly better.
Yeah, 144.
Yeah.
Can you share this code?
Sure, I'll do that. Yeah.
In this visited set, you are maintaining all those coordinates you have visited already, right?
Right.
Okay.
Yeah. But I'm just creating an integer. Earlier, I was creating a string. So I think, string manipulations take more time, and therefore it was giving me not so good time run time. So the way this also actually got some clue by looking at the discussions forum, and then I could come to this. So this worked slightly better. Yeah, but I think DP is much better. But this was slightly intuitive to me because it was like a BFS, and therefore I started the app the way it was described in the first one.
This is more intuitive. Yeah. I mean, everybody will get BFS only. DP and I don't know.
But I didn't come up with these things. I had to refer to the discussions because then you have to specifically look for these only, because or else if you do it, compare it for each and every movement, it doesn't make sense, right? You have to specifically look for only.
So this I variable is related to the possible directions.
Sorry, come again, please, Arshad.
This can you move your screen up? I mean, can you move upwards a bit? So these are the 4 directions, right? Okay.
Yeah.
Yeah.
So these are the 4 directions, but still these are the hard-coded ways, to look for if it is anti-clockwise and clockwise. It's not a good way of doing it, but yeah, that's slightly optimizing the code. Or
how
usually
did you
what?
Get yeah, go ahead.
If I equal to 2, then that means what? Like.
Sorry, come again.
No, I equal to 2. That means what does that suggest?
That is clockwise. So if you look at this one, so this is I equal to 2, yeah. So this is the clockwise and this is the anti-clockwise. Or else in a normal BFS, we won't have these conditions, right? So is I equal to and I equal to 3. We'll just look for all the valid cases. But here we have that very specific way of looking at the snake. Whether it is in horizontal, then only it can go clockwise, right? Or if it is vertical, then only it can go anti-clockwise.
Yeah.
So those are the very 2 specific conditions. So we have to do it this way, and this was not possible. I just did it earlier. I did without looking at that, and it was not at all passing many test cases, right? So then I just looked at the discussion forum and found out this one. So I added that, then it at least it was getting accepted.
How did you get rid of this check I equal to 2? I can see in one of your solutions you showed that you're not checking this.
Oh yeah, then actually I started doing for each and every one separately, right? So I did it for vertical movement. Yeah, so that's a very big way of doing it. Yeah, it's not so normal way, but yeah, this is fine. I at least explicitly do for each and every direction.
It's very intuitive.
Yeah, it's very clear. It's too much of code, but it's much better. Yeah, I'm sorry for the noise here. Okay, yeah. Shashank, yeah, you can.
Now you can probably optimize on the indices, I believe. A memo array where we check whether we have traversed a particular index or not. Maybe.
Yeah, maybe. Yeah, that's true. More things to optimize to, yeah. Yeah, no problem. Shashank, yeah.
So I also got a partial understanding, and let's see what happened. Something got changed, right? The view got changed. Okay. I don't know. Something here got changed.
You can go to your submission.
Yeah, you go to the last one, yeah.
Yeah, it will work. No problem. So yeah, what it? Okay. Yeah. So what it is they are doing is like they are first checking whether your horizontal is free or not, or horizontal is not free, right? Like if horizontal is free, I mean, if you can go forward, then they are checking these possible directions, whether you can go further ahead or you can go vertical down. And this is like vertical they are checking. I mean, if horizontal is false, then it will have possibility to go into the downward direction, and there it is checking for what do you say, whether you can go horizontal or whether you can go again vertical. So we'll see here. So let's say if horizontal path is there, then they are check. This is the base. I mean, they are checking whether horizontally if they are going, then C plus 2, because every time the snake spans, it will take two cells. It will span two cells whenever it moves. So it is checking whether you are inside the boundary and those two cells are equal to 0 or not, because if it is equal to 0, then only you will be able to move forward. And then
Yeah.
And this is for moving to the right. So for moving right, what they are doing, your row is same, column they are increasing by 1, and again they are setting these are the four parameters: row, column, and horizontal, and rotated. So when they are moving to the right, that means they are covering one column. Row will remain the same, but they are covering one column, and horizontal is equal to true. That's why they are able to move. And regarding the vertical, they have set it as false because they are not able to move in the vertical direction here. And for moving down, they are again checking this condition, like if r plus 1, I mean, if it is less than n, boundary they are checking. And all the below cells, this is all the four cells should be equal to 0, then only it will be able to move in that case. So if it is moving down, then definitely one row it will cover, the column will remain the same, and they are setting horizontal to true and rotated to false. This one I didn't get, like, it should change right here. They are making it as a true only.
No, so in this case, what he's doing, he's still in horizontal position, but he's moving down horizontally, right? So what
Down.
he's doing, yeah. So what he's doing is, if he was on the first row, he's completely jumping the head and tail all together in the second row.
That is not possible, no?
That is possible.
Entire body shifting.
Yeah, entire body shifting, horizontal or vertical, that is fine.
So he's not changing direction.
He's not changing the direction. Yeah, he's not going clockwise or anti-clockwise. He's just remaining the same position. Means if it's horizontal, he's horizontal right now, right? So he remains horizontal. But whatever is the row he was, he's just moving one row down.
But won't that be rotation?
No, it won't be rotation. So
without
rotation is
rotation, how will
below.
he move?
He's doing rotation in the line 28.
This one.
Yeah.
But how will he move to the below? I mean, entire body. How will that entire body move from row 0 to row 1 without
Yeah,
rotating?
he can move if there are zeros below that.
Okay.
But that direction movement is possible. They are not saying that you can move it that way.
Oh, okay. I mean, so direction is like either he can move horizontal, vertical, clockwise rotation, or anti-clockwise rotation, right?
Correct. Yeah.
So if he is lying horizontal at row 0, so he is directly jumping to row 1, the entire body, the body and the head, right?
That's right. Yeah.
Okay.
I can't visualize that.
Yeah, that was
Okay, I'll just show if you can open that board. But only one thing I want to actually mention here, Shashank.
Yeah.
This is a DFS approach. It's not a DPA approach, right? It
Yeah,
looks to me like a DFS approach.
DFS only. Yeah, I mean, spanning the cells. Yeah.
Right.
Because we are not using any memoization or anything like. No, but here I'm storing the values in my.
You are using memoization, yes.
Yeah, but. Again,
Yeah,
but cache.
it's a very good approach. Yeah.
Okay.
Yeah, can you just quickly just go to the description and go to that?
Sure.
I'll just show you.
Okay, edit code. I have to do that. Yeah. Yeah, if the snake is sorry. So if the snake is here, how can it move directly here?
Yeah, just a minute. Okay, I'll just show you.
Okay.
Okay. Okay, this is okay, right? So if your snake is here, correct? Okay. So in
Yeah.
your case, when you want to go horizontal down, you can go directly like this. That is perfectly legal.
So where it is mentioned like that moment, which moment is this?
This is horizontal. You are horizontal, but you are moving vertical now. The whole body is moving vertical.
Okay.
So if you go up, yeah, this first one, okay, first to one. See, if he says move one cell to the right if they are not blocked cell, this move keeps the horizontal vertical position of the snake as is. And if you look for the second one, move down one cell if there is no blocked cells there. Okay, this move gives the horizontal vertical position of the snake as is. So if you see horizontal / vertical, okay, in
Yeah.
both cases it's saying. So either whether if it's in horizontal, he can go horizontal or he can go drop down vertical also. So that is what they mean here.
Okay, I mean I get it now, but is this movement one cell movement, like when we are changing the rows?
Yeah, it is
No,
one
it-
cell,
Is that a one
unfortunately.
cell?
Yeah,
they
unfortunately.
mentioned it will span 2 cells.
No, the snake will span 2 cells, but the movement is only one movement. Yeah, Harshit, I get your point.
Okay. But then what is the use of doing clockwise and anti-clockwise like this?
Well,
No.
so it depends, right? The way you want it.
Yeah,
Because
yeah.
when you are going in the 11th, you could actually make out, right? If you go slightly scroll down, when we were actually working on that, yeah, when you were very at the very end, right? So we
Yeah.
were somewhere here, right? So then we had to move it this way, correct? And then
Yeah.
again drop down, correct? And then you can move it like this, correct? So
Yeah.
in those cases, it is very useful.
So there we could have moved direct vertically itself.
Yeah, you can move it vertical also, but still again you go it this way, right? And then you actually drop it down.
No, again vertical.
If you imagine that is slightly not possible, okay, but okay, let me come actually what you as per what you say, okay. So see, in this case, if you are here, right, so you are saying you go again here like this,
Yeah, yeah.
okay, and then what
Yeah.
you want to do?
Again one more vertical like that.
Again one vertical, okay.
Yeah, so
So
it
then
is
you cannot move like this. You cannot move like this because this is your tail here, correct, and this is your head. So you cannot move
yeah.
your tail. Your head also only has to move, not the tail.
Oh, head has to span,
Yeah.
yeah.
So in those tricks, you have to use this one. Yeah.
Yeah.
Yeah. I'm sorry, you are going through that walkthrough.
No, it's good. Yeah, I mean that made a bit clear. Yeah.
Yeah. Go ahead.
We were now so our horizontal got over. Like this was the doubt. Yeah. Next is like again for the vertical, same thing we are repetitive code it is. Like if vertical we have to go, we are checking whether the next two rows next two rows should be, I mean, they are checking the condition like it should be within the boundary and those should be filled with the zeros. I mean, if it is free, then it will go move down. So once it moves down, the row will be occupied by one, column will be as it is. And yeah, horizontal will be false. That's true because there is no movement in the horizontal and no rotation we are doing here. And the other case is this one where we are moving right. So again, this is the condition we are checking that we are not going beyond the boundary. And if next two, what do you say, next column and row is free, then you can move to the right. So while moving to the right, the column will increase, row will remain constant, and this is the horizontal direction is false, yeah, because we can't move, and rotation here is again false. So we are directly moving the body, right?
Yeah.
Vertically, yeah. And if it is a rotation, if not rotated,
So earlier
then
not rotated, yeah.
okay. And just we are showing the minimum values of V1, V2, and V3. I mean, V1 is this, V2 is this, and V3 is this.
So earlier, if it is rotated, then we are not rotating it again. Is it like that?
Pardon? So once we have rotated, then?
So if it's not rotated before, then if our rotated is true, then we are not rotating it again.
Yeah,
No, actually,
we are not
what he's trying to do is, if we are in vertical now, so he's trying to first move down, okay? It's a DFS approach, right? So you move in 3 directions here. If you are vertical, you are either move down and see whether it's a minimum. So he keeps that value in V1. Then he moves right, keeps that value in V2. And if it's not rotated, then you rotate yourself and then keep that value in V3. So whichever is minimum that you actually keep in the cache, right?
Right. So what I am confused with is that if why only are we rotating if it's not rotated before? Why are we just not rotating as a third option?
Okay, that makes sense. But I think, when it is vertical, so the way they are saying, it's like we want to start from the top left position, right? And we have to go to the bottom right. So the way we can go is either we go down or to the right side.
Yeah.
So only 2 directions actually can go. So in that case also, when we want to rotate, we can either go, when you are vertical, you can only rotate to the anti-clockwise direction. So you are actually maintaining the flow of going bottom right, because you don't want to go to the other again anti-clockwise. You don't want to keep rotating it. So you just want to rotate only once.
Okay.
Something like that, yeah. Means that is what I would,
Basically, not going in a circle.
Correct, yeah.
Fine. Okay.
Can anyone?
Yeah, it's a very hard way of actually understanding this. Yeah.
Yeah, well, I have a query. May I?
Yeah.
So, can anyone make sense of me that 34th statement, instruction number 34?
Yeah, so it's checking whether you're not your column should be less than n and your row should be also less than n. I mean, you are not supposed to cross the boundary.
Yeah, fine.
And the second condition, it's checking like both the row and the column should be filled with the zeros for moving to the right. Because if it is filled with ones, then in that case you can't make movement in the right direction, right?
Yeah, so you are blocked. Yeah.
Yeah.
So those cells are blocked. So you have to check if the cell values are zeros, then only actually you can move to the right or you can rotate.
So this one, like this is blocked, right? These two are blocked.
Yeah.
So you can't move here. So
these are the invalid states. Yeah.
Yeah, invalid. Yeah.
And instruction number 40, we are adding +1. +1 means that we are just moving one head at a time. So that means the previous one is already existing. We are adding that one or any something.
No, this is the one actually when we are doing, right? In this case, from line 31 to 39, there's V1, V2, V3, whatever we are getting, this corresponds to that one. Okay.
Okay.
So that is the current movement what you have done. Yeah.
So I'm just wondering, like the way Santosh did it, if we do not maintain these two variables, this horizontal and rotated, and just check whether it's valid or not, then I think it would be the same approach, right? Apart from that, it was BFS and this is DFS.
Yeah. Yeah, that might
work.
Be right to say, yeah.
to rotate only once. Gets a bit complicated.
Right. But it's more thoughtful the way whoever has actually implemented this.
Yeah, I mean, too
Yeah.
much of thought he has given.
Yeah. Because the code looks very concise, right? It's not too
Elegant,
much
yeah.
of code.
And I mean, it's repetitive only, right? I mean, if you know logic from line 18 to line 28, just the reverse of it is doing in 29 to.
Yeah, that's for the
Where is
vertical
the
and the horizontal.
Yeah.
Where is the memorization part implemented?
Yeah, there's a cache in line 40.
Yeah, that is
40, yeah.
memorization. Yeah.
So
So it's
do
a
we check
DP
when
only, right? Some or
Yeah, so first you do a DFS. So DP is like actually first you do a recursion. You have a recursion relationship. That is the way I look at it. I'm not saying that it is not DP.
yeah.
So first, actually, you do a recursion. You have a recurrence relationship. You do all that stuff, and then if you are not able to attain the time complexity, you add the memorization. But yeah, DP actually goes the other way. You have to find if it's an overlapping sub problem, and then the other condition, right? So both conditions
think-
should satisfy.
Depending on the choices, he might have termed it as DP. Like
It is a DP actually, yeah. But the way I was thinking, it is a DFS, and then he is adding all that.
yeah, yeah.
Can you move a bit upwards, Shank?
Sure.
Where is the caching part checked? Okay,
The
if just line number
this one.
14.
Yeah,
number
and
14.
line of 14 is taking it. Yeah.
Okay.
It's a top-down approach. It's perfectly right. Yeah.
Yeah, it's a top down. Yeah.
Yeah. Earlier, it appeared to me it's like a DFS. Then I didn't see the cache properly. Yeah. And then I came to. So it's
Mid part is
Python,
DFS.
right? So I actually always think on the C++ way. So, yeah. Yeah, this is also good solution, right? Now, at least we understand it. Maybe next time if someone will come across this problem, we should be able to implement it this way, right? Should not be a very difficult thing.
A lot of clarity is there, and that will move.
Yeah.
But there are two cases. One is horizontal, vertical that you have to surely say. But in horizontal, you have to consider another three cases, as well as in vertical. Yeah. So V1, V2, V3, right? Yeah. So that those three cases we always have to consider.
Yeah, that row and column surfing was something I couldn't really understand.
Yeah.
Changing at the row. Yeah.
So in horizontal itself is going three ways: horizontal, and then moving to the right, down, or clockwise or anti-clockwise.
Yeah. So in both, like horizontal, vertical, both. It's time for all the options.
Yeah.
Yeah. Cool.
Yeah.
Santosh,
Overall,
please
it's
share
in
your
order of.
code.
Yes, sure. I'll share it.
Yeah. So yeah, what will be the time complexity? Yeah, we forgot to mention that.
So it's a recursive also. How to say?
So we have 4 states here.
Mainly 2 states only: horizontal and vertical.
I think it is going to be R into C only.
So if everything was 0, okay. So all cells were 0. Yeah, it will be very easy to implement. It will be the efficient way of coming down. It will just look for all zeros, then it will come within very small moves though. But we still have to check for if it's a DFS approach, right?
Yeah.
If all are zeros, it's pretty straightforward, right?
No, I think what Harshit says makes sense, right? It will be O of R into C, correct?
Yeah, it will have to span all the rows, columns. Yeah.
I think so. It should be O of R of C, R into C. Yeah.
Because apart from that, we are not seeing.
If we go the BFS way, then it will surely be R of C, correct? But DFS, we always go through one way, come back again, and you are not keeping anywhere. You are not maintaining though you are maintaining that cache, which is memoized version, if you would have not maintained the cache, then actually you
Will fall in
you
a
would have,
circle.
right. You would have to maintain something like a visitor also, right?
Yeah, then.
So in that case also it will be ORFC, yeah, because we are
Yeah,
not visiting the same thing.
I think
So
that
here you're
use of visited is being prevented by DP only.
cache.
Right,
Is
yeah.
normal DFS, we maintain that visited thing, but in the DP we can make use of, if it's not -1 or any initial value, then we have already done for that state.
Yeah, makes sense.
Yep.
So O of R of RC, that is the best way to say. Yeah.
Worst case.
Yeah.
And Santosh, your code was exponential, right?
Mine was a BFS, right? It will be the same almost.
Exponentially won't pass test cases.
Were you caching it?
No, it was. I was not caching it, but
Okay.
okay. Let me also go through it again. And you said, but it's not exponential for sure.
Visited
Because
was
I'm using visited. I'm using
Yeah.
visit.
Okay, I see.
Yeah. So because BFS also won't work, right? If you don't use visited something, right? So and then you go through each and every level, and you just put in only those cells which are not visited.
Correct.
So it makes again R of C.
Yep.
Yeah.
True. Yeah.
Cool.
Good discussion.
Yeah. That was
Yeah,
good.
it was a nice one.
At least we understood this, the DFS route also now. Now it's very clear, yeah. Okay. So let's call it for today. Yeah. Thank you, Shan.